8.4 Laws of Logarithms, also known as log laws. The log laws are directly related to exponent laws. The log laws can be used to simplify logarithmic expressions if all the logarithms have the same base. Now the following note: provided that a is greater than 0, x and y are also greater than 0, and a does not equal 1, the following laws are true. Okay? And a law allows you to use it forwards and backwards. First one is known as the product law of logarithms. The product law states the following: if you have the log of a product, you can change it so that you have the sum of the individual logs of each part of the products. So, and this, if you think about it, is very similar to what we did with exponential equations. If we had two bases that are two powers being multiplied, you can add their exponents. So that's what this is actually saying. So the product of two bases will equal the sum of the individual exponents. So the product of two powers is equal to the base with the sum of the exponents. So that's what the product law of logarithms looks like. The quotient law of logarithms looks like the following. If I have the log of a quotient, that equals the difference of the individual logs. So the log of the numerator minus log of the denominator. Note though, for all of these, including the third one I'm going to show you, they all share the exact same base. So the power law is the last one. The power of a law of a logarithm you've actually used since grade 11. The power law of a logarithm says that if I take the log of a power, that is equal to the exponent times log of the base of just the base of the exponent of the power that you're originally taking the log of. We've already been doing this. We've taken this r, brought it to the front, and multiplied it to get these values. So these three laws are very much in use whenever we're dealing with logarithms. We want to simplify expressions a lot of times using one or more of these log laws. All right, let's move on to an example. Example 1. You're asked to simplify, then evaluate without a calculator. So you have the following. Now, with respect to the first one, note that all of these have the same base. And if we were to change this back using the power law, we'd be able to use one of the log laws. And we would use the product law. The product law states the following. This is all the same base and they're all being added. So the log of the same base is equal to 3 times 3 to the 3, that converts this from a power law, times 81 to the power of a half. Again, the log with the power law is used there. All right. Now, note, log of 27, log base 27 of this is equal to 3 times 27 times 9. What that means is we want a base of 27. Why do we want a base of 27? Well, because we have a 27 base here, and that will help us, hopefully, to get the final answer. And lucky for us, when we plug it in, we end up getting 27 squared. So the log properties that we learned, the log base 27 of a base of the same base with an exponent is equal to just the exponent. Now I want you to note, you may not have seen it this way by using the log laws, and you might have seen that this is actually equal to 1. So let's look at an example. Log of 27 of 3 is equal to 1/2 log base 27 of 81 plus 1. The reason where the plus 1 comes from is from here. Here, it's log 27 of 3 to the 3. 3 to the 3 is 27. So you have log base 27 of 27, which is equal to 1. That's where the 1 came from. The other two, we just rewrote them, convert them, because we know that the square root of 81 is 9, and we know we can do the product law here, plus 1, And then 3 times 9 is 27. Log base 27 or 27. And we know that answer is just 1, so it's 1 plus 1, and the answer is 2. So whether you do it the red way or the blue way, I guarantee, folks, you'll get the same answer. Let's look at the next one. Log base 3 of 448 minus log base 3 is 7. So, using the quotient law, 448 divided by 7 is equal to 64. And then you'd simplify this to log base 3 of 4 to the 3, which is 3 log 3 to the 4. Now, how would we figure out what that value is? Let's say if you needed to approximate it. So looking at this, where did I get this statement? Well, that's saying this here, 3 to the power of something is equal to 64. So if I have a cube base, so the 3 is your base, 3 is your base, here's my 3 to the x. We need to find out when it's going to hit 64. Well, it's going to be between 3 and 4. 3 to the power 3 is 27. 3 to the power 4 is 81, and that's where the 3 and 4 came in. And we need to find the value of 64. 64 is close to 81. So the number should be on this half of the graph, closer to 4. So let's say 3.7. 3.7, 3.8. That would be the most it could be. Either way, you could try and figure out what that value is. Example number 2 expresses a single logarithm. So looking at these two examples, we're going to express these as a single logarithm. How do we do that? 2 log 8 plus log 9 minus log 36. We note that they're the same log, or they have the same log with the same base. Because of that, we can use the log laws and log properties as we know them. Log base 8 of 2 is equal to, now let's rewrite it, log base 10 of 8 squared, log of 9 minus log of 36. So what we have here is converted everything to a log, and then we use our log laws, which will be 64 times 9 divided by 36. And you could do that with a line over it or the division sign. Either way, it's the same answer. And log of 64 times 9 divided by 36 is going to be log of 16. Because the question doesn't ask to give us the answer. It just says express as a single logarithm, which is exactly what we did. So, give yourself a chance for a second to try and do the second one without me showing on the video. So I'm going to pause the video now and have you think about this question. Okay, hopefully you've given yourself a little bit of time. Let's move forwards. Convert this so that it equals x cubed. This will be x squared, and this will be just y. So we're going to add, so that means we have to multiply x cubed times x squared, and we're going to divide, because it's subtraction, by y, all with a log of base 4 in the front. Simplifying this, we will get log base 4 of x to the 5 over y, because here we have two powers being multiplied, so we add the exponents, and that gives you x to the 5 over y, and that's the end of the question. We can't do any more. All right. Example number 3. Solve log base 3 of x minus log base 3 of 5 is equal to log base 3 of 6 plus 2 log base 3 of 4. Notice here that we have log base 3's all the way across, so that will help us. The difference is that on each side we have more than one log. So how about we try to aim to have a single logarithm, at least on each individual side. So when we do that, we will have log base 3 of x over 5 is equal to log base 3 of 6 times 4 to the power of 2, which is 16. How does that help us? Well, now we have log base 3 of x over 5 is equal to log base 3 of 96. How does that help us? Well, we have the log of both sides. So if we have the log on both sides and they're single logs with nothing else there, what we can do is drop the logs. just like we would do it if they had the same base. We would drop the bases and make the exponents equal. Here, we're making the arguments equal. So x over 5 is equal to 96. That means x is equal to 480. That's how you solve for this particular question. Another way to solve this exact same question, there are 3 different ways we're going to explore. This is the first way. Second way to explore this question is to do the following. Move everything to one side and make it equal to 0. Convert it so that you have x divided by 5 divided by 6 divided by 16. So all those numbers get multiplied on the bottom. And so what we have is a single logarithmic equation equal to a number. What do we do now? We take the base to the exponent equal to the argument. And this is the argument here is going to be x over 480 is equal to 3 to the power 0. X to the 480 is equal to 1. X is equal to 480. So the value of the answer to this is x equals 480. When I plug it in here, we will get the same right answer. This information here is to remind you of how to convert a log to an exponential, or an exponential to a log. Alright, the third way to look at this question is to do the following. Log base 3 of x, so the one with the variable stays here, and everything else goes to the other side. And this is what we get. Once we do that, we can then take this and convert it to a single logarithm, which is exactly what we did. And then we have log base 3 of x is equal to log base 3 of 480. And this, folks, at the end, this is the final answer, which we've had all 3 times. Why? Because I have the same log with the same base on both sides. Drop the logs, we get x is equal to 480. And there's your final answer. Alright, that's the end of the video, folks. Take care. Have a good night.